Hello everyone, welcome to the latest in our automation competence series. Today we're here to talk about distributed control in factory automation with Bram Scheidegger. Hello Bram.
Hi Jeff.
What can you tell us about distributed control in factory automation?
So distributed control is an architectural design pattern where you split the tasks into multiple subtasks.
Okay, what's the advantage to a customer to do something like that?
Well, with that, you reduce the overall complexity because you have, instead of one big complex problem, you split it into multiple small sub-elements and you can work on each individual sub-element independently. So for example, when you commission a system, you can commission each part separately, test each part separately, make sure it's up and running, and then connect it to the factory automation network.
Okay, when you do that, does it take more engineering?
No, absolutely not, because usually you can buy these local modules from a third-party manufacturer, which are experts in that field. And then you have like the pre-programmed application in there, which does the job for you. And it has also another advantage. You have only one industrial Ethernet wire going there. You don't have the problem that you need to run 10 wires there and find out if there is a problem, which wire is now broken or is it in the right place, especially if it's 100 meters away, right?
Okay, so when everything breaks down and you have to fix something, you can just plug and replace or plug and produce.
Yeah, or go at the machine and look at the local wiring because everything is wired there and it's an encapsulated machine.
Okay, troubleshooting is a lot easier then.
Troubleshooting is a lot easier, but you also get much better reaction time, and this way you can run your machines faster because that particular module is focused on a specific task, so it's only doing that.
Okay.
And then sends the final result to the PLC, to the higher level system in that sense.
Okay, can you give us a concrete example from our industry?
Yeah, absolutely. So in weighing, you see a lot of examples like tank weighing, filling, or for example, in motion weighing. When you have a conveyor belt, an inbound light barrier, an outbound light barrier, and you want to capture the weight while it's moving. There, you want to know when is the item entering, then the light barrier is triggered, and you want to know when the item is leaving, and in between you want to capture the weighment. And this is really time critical, because I cannot wait 50 milliseconds, 100 milliseconds until I know, oh, there was an item and now I need to capture the weight. I need to know that immediately. Process that and then send the final result of that item to the higher end system.
So the overall controller has time to do other tasks because we're doing our specific task in a distributed control.
Absolutely, yeah. So it can show the HMI, it can aggregate data, and it can control the overall factory, which needs a lot of coordination, right?
Cool. Now we hear many times about smart factories, the combination of OT or automation and IT. How does this affect distributed control?
Well, the distributed control architecture is very well suited to match this IT-OT convergence. I just spoke about sending data to the PLC. That's one part. So the local unit processes the data and sends the data the PLC wants to the PLC, like a weight value, a status information, that what it needs further downstream.
Right.
The IT system is interested in maybe other data points, in more data for processing. And the local unit can create from the data it captures information, so useful information which has some meaning, and send it to the IT system. Because that local unit has the domain-specific know-how about that system and can make sense of the data.
Okay, that makes sense. So I have control, local control for the OT part of the system, and then I'm sending data out to the server or to the cloud so I can analyze the data and look for potential improvements in the process.
Yeah, and the IT systems, they are very well equipped to have large databases and do really data crunching up there.
Oh, that's really cool. Now, sometimes I hear about distributed control systems, like DCS, a box called a DCS. Is that related to what you're talking about?
It's actually a bit of a confusing naming because a DCS is actually a centralized control system. It has all the wires going in there and does all the processing by itself. You see it a lot in process industry. So it's really like a centralized control. You can compare it with the previous IT world where we had these big mainframe systems like 20 years ago. And now the industry moved also towards a more flexible distributed control mechanism. So this is like a similar paradigm shift taking now place in industrial automation.
So we're looking at distributed control adding the advantage of speed, lower engineering, modularity.
Yeah.
So these are all good reasons to move in that direction.
Yeah,
So
it
this
has
is
a
the
lot of
future.
advantages. You need a proper architectural planning, how you want to wire it up, but in the end, having modules is a very good architecture because it reduces the complexity of a factory.
Well, I'm excited about this modular control and distributed control systems. So Bram, thank you for your time today, and thank you all for listening to our video series.